So, what is game theory? Game theory is modeling the behavior of people. When you use game theory, there must be set rules, and the people are assumed to be completely rational and strategically make the best choice. So they maximize their payoffs and not like overall payoffs. And this is going to be important later. Game theory is often used in economics. Simple game theory situations. The first one is prisoner's dilemma, and it's pretty famous. You and your friend are both being questioned for a crime separately. Both of you have two options. The first option is to say nothing, and the second option is to confess. The scenarios are, if both you and your friend say nothing, you will get 1 year in prison. If one of you confesses while the other says nothing, the person who confessed gets out free, and the person who said nothing will get 3 years. If both of you confess, then you will get 2 years. Okay, so what would you do? And Zyad already said the answer. So, okay, the solution is, so Zyad was right. Everyone will confess because everyone will maximize their own payoff and not like the overall payoff. And that's assuming that everyone is rational. So the logic is right here. If your friend says nothing, you get 1 year, but if you confess, you'll get 0. If your friend confesses and you say nothing, you'll get 3 years, but if you confess, you'll only get 2. So your friend also has the same solution because they are also assumed to be completely rational in game theory. So both of you will always confess, and this is called the Nash Equilibrium, where the outcome is settled because both of you will get 2 years no matter what. Okay, split or steal. If both parties choose to split, both will get $100. If one party steals, I made a typo. They will get $500 and the other gets nothing. If both parties steal, both get nothing. So applying the same logic as prisoner's dilemma, what would you do? You guys can talk.
I'll get nothing.
Yeah. You mean steal, right?
Yeah, probably steal.
Yeah.
Okay, it doesn't make a lot of sense because no one is going to get any money, but the solution is for both parties to steal. And yeah, game theory says people are terrible. And this is at the Nash Equilibrium again. Okay, construction game. So you are hired to build a shed for $2,000, which you're paid before you build. So the shed is worth $2,500 to the person who's hiring you. So if you build the shed, they're getting $500 of worth. So the best thing for you to do, if it's just one time, is to walk away with the money and not build the shed for them. Because you get the money and you don't have to build. If you're guaranteed to be hired 10 times, the same thing will happen each time. But if you add a rule where if you walk away with the money once, you won't be hired again, and this is the type of game where you don't know where it ends, and each time there's only 10% chance of it being the last shed that they want. In this situation, it's actually best to constantly do the work because you have more chances of getting money rather than if you were just to walk away and never get hired again. But it would also be kind of unfortunate if the first time is the last shed that they want. Okay, more complicated theory. It's just, I added a lot of types of games. So the first one is cooperative versus non-cooperative. And Prisoner's Dilemma is an example of a non-cooperative game, where a model is used if each person were to maximize their individual payoff. So they care about themselves and they don't care about anyone else. And its opposite, cooperative games, are model. It's more used in real life because there's something called enforced commitment, which is being enforced outside of the game, and there's contracts in real life which you have to follow by law sometimes. So cooperative games are used for real life more. Oh, but the last thing is cooperative games are often used because they're a lot simpler, because like real life, there's like many parties and the rules are really complicated. While non-cooperative game models are more complicated but also more accurate. But like if you have like 1,000 people involved, you wouldn't want to like solve for all of them. Symmetric/asymmetric. So Prisoner's Dilemma is an example of a symmetric game where you and your friend have the same set outcomes. But let's say if the jailer just doesn't like you and you have longer sentences than your friend for like the same outcomes, then that would be asymmetric. Okay, zero-sum games. Zero-sum games is where the amount of resources will always be the same. So for example, in poker, the chips are the resources, and they basically stay the same if you like ignore like paying to play and stuff. But like the amount you can win is like set based on how many chips are there, and the loss and the amount won adds up to 0. So they really creatively named it zero sum. Simultaneous/sequential. Simultaneous is each player makes a decision at the same time, which is Prisoner's Dilemma, while sequential is going one at a time and getting the information of what they did, which is poker. Because also if the two in Prisoner's Dilemma are going one at a time, but they don't have the information, the game is still simultaneous. So like the important thing about sequential is knowing what the other person did. So like in poker, if someone like puts out a lot of chips before you and you know that, then you can probably think that they have a good hand or something. But in Prisoner's Dilemma, which is a simultaneous game, you just don't know what the other person did. But it doesn't really matter because everyone's just going to confess anyways. Relation to computers. Algorithmic game theory, which is predicting the behavior of people using game theory and developing algorithms based on it. Okay, so the main way one example of this like used a lot is like setting routes. You know how you like go on Google Maps and it tells you where to go and then you follow it? But this is like a lot more complicated than just calculating like miles per hour and whatever and distance. So the computer has to create an optimized route for you and for other people. Driving on one route, it might be the best for you. Like it could be the shortest distance with like the highest miles per hour and whatever, and it would take the shortest time. But if that one route is the best for a lot of people, the algorithm sending everyone on that route would cause a lot of traffic, and it's possible that they could send so many people that it would be worse than if someone went on a different route as opposed to that route, which was like originally the best. So the system has an algorithm to like determine how much traffic will be there, and like if the route is like really the best option. And that's the job of computer programmers to like figure that out with game theory. Okay. This is one more that's like similar to that, but it's a lot more related to computers. It's called the K-server problem. And so you imagine a space where a set of servers are represented as points, and requests keep coming that are also points, like points in the space, not like points as in number. Each server moving to a request would complete the request, and they move depending on algorithm that it's a computer programmer's job to make. So the goal is to have it so the servers move the least amount possible. And the problem with this is moving to the closest one is not usually the best result, and it's better to like know ahead of time. So if you know that a lot of requests come in a certain spot a lot, you could just have one of the servers like stay in that certain spot and wait rather than constantly moving around to the closest request and let another server handle some other request. And that could like potentially shorten the amount that they have to move.
Wait, can you go back to the zero sum game? So that's
Sorry?
just saying that if like one person loses, another person gains.
Yeah.
Okay.
But like the total profit and loss cancels out to 0.
Okay.
Are there any other questions?